Welcome to Software Minimalist channel. My name is Piotr, and today I will talk about the two perspectives of software design, function and structure. Any software or any engineering project, for that matter, can be viewed from two perspectives, which are mostly independent from each other. One is a functional perspective, which describes what is the function the software is supposed to fulfill. The second perspective is the structural perspective, or how the software is built, what modules come together to achieve the function. These two perspectives are mostly, but not entirely, disconnected. We can do a simple thought experiment to realize this. Imagine some functionality, any functionality, and think about multiple ways it can be achieved. If you can figure out some function which can be performed in many different structural ways, you just prove the point that the functional and structural view are mostly orthogonal. Now, which of these perspectives is more important? Functional view is the more important one. Why? Because it is directly connected to the needs of the customer and the problems they want to solve. For a software solution, it is by far more important for the backlog of work items to represent intent rather than structure, especially on the high level. I should be able to understand why things are in the backlog. Imagine we want to hammer in a nail. We can use either a hammer, a rock, even a wrench. There are more than 50 types of hammers alone. Some tools will be better than others, but the point is the driving in of the nail. The selection of the right tool may be a question of efficiency or whatever is important in the context. Some time ago, I made a post similar to the following. Nobody cares how the engine is built. They care that it moves the car forward. By nobody, I of course don't mean literally nobody. Obviously, there are many people who do care. The engineers, the designers, me and probably you, but not the users. Customers do not really care about the architecture we choose as software designers. They care about the results. This is precisely the reason why user stories and agile ways of working are defined the way they are. Because they are not about the structure, they are about the function. Now, why am I talking about this? Through the years I spent designing and delivering high-throughput distributed systems, I found, or rather figured out, that the description of function is often neglected, if not ignored entirely. Software architects and developers focus almost exclusively on the structure, for example, class relationship diagrams, thinking the function is the obvious part, where it is exactly the other way around. Backlogs represent the technical details of the design. Names used for user stories are written to be only understood by developers. The descriptions do not convey the context or even the use case. You see stories like implement interface for transaction module. Why? For what purpose? What functionality does this provide for the user? It might be obvious for the software engineer who wrote the item, but not for anyone else. How do we prevent this? A solution should be represented with both a structural and a functional view. Here you can see a dependency diagram or stack demonstrating the structural view. It's an example made available by Lucid Chart on their site. Functional view should be represented with a collection of sequence diagrams explaining the flow of the intended functionality, as you can see on the screen now. There is a wonderful video by Lucid Software about sequence diagrams, which I will reference and link in the description. This is what goes into the product from a structural perspective, and this is what goes into the product from functionality perspective. Imagine a bridge. It has both a function and a structure. Describing it as just one of these is incomplete. They are orthogonal, with the function being far more important. Why are we building a bridge in the first place? If we never considered the function, we might have missed a different way to cross the river. A ship, for example. Sequence diagrams translate directly into user stories and capture the business functionality. They are vertically testable and individually deliverable. The simplest, most scalable and powerful representation of work I ever found. Dependency diagrams and changes to them typically result in architectural items or tasks. an item under the user story. They should live on the same level as parts of your definition of done. Sequence diagram-based user stories cut through the stack vertically, which allows to easily prove work is done, test, and deliver it. Sequence diagrams enable vertical integration. One thing about agile teams you may be heard before is that they should be cross-functional, meaning they should have all the skills to perform vertical integration without external dependencies. This is why. Dependency diagram-based architectural items cut horizontally. For example, imagine the entire database module version 1, which unfortunately means it is difficult to prove they are correct and work with integration testing, and we must rely on unit testing. But I hope folks are at least doing unit testing in such scenarios. However, only relying on unit tests and doing an integration at the very end, or even being too late with integration, is a well-known recipe for waterfall-style disaster. The only way to deliver quality software faster is through early and continuous integration and delivery. That's not even controversial anymore. In 2023, I hope everybody knows this, right? The dependency diagram with versions of modules and components can and should be used as a basis for the configuration management and infrastructure management. For example, config files, Helm charts, Ansible playbooks. Think of configuration as code or infrastructure as code. So a simple text representation of software stack is already helpful. Small twist now, here's why I love sequence diagrams. A single sequence diagram can actually show both functional and structural perspective, depending if you look at it horizontally or vertically. You can see dependencies on a sequence diagram. You can even see entities on a sequence diagram. Turns out many other types of diagrams, including dependency stack, can be viewed as just a special case of a sequence diagram. One last idea. What if you have a new version of a feature which already exists, or you found a bug? Your original sequence diagram simply becomes the previous version, and through versioning of sequence diagrams, capturing the difference between the old and the new, you have achieved a way to handle anything a project could throw at you, without ever needing to invent any new type of paradigm, process, or item type. This is the reason I ask my teams to always produce sequence diagrams for use cases and user stories, version them as requirements evolve, and only consider a problem understood once a logically consistent and complete sequence diagram has been produced and shared with all stakeholders. If there is anything inconsistent, it will be already visible here before any coding starts. I had countless situations where the existence of a sequence diagram and the visualization of some flow helped stakeholders understand this is not what we need before any coding was done. The ideal bug fix. In this view, there is no bugs. It's always just new versions of sequence diagrams representing the needs of the customers and our way to satisfy those needs. Thank you all for joining me today. Please like, subscribe, and share. Provide super thanks or Patreon support if you can, and have a beautiful day. Until next time, your software minimalist.